All right, so today we are building off of what we did prior on Friday. And so on Friday, we talked a little bit about solving trig equations. We're going to continue that today, adding some wrinkles to that. But to start off, let's do some easy bell work. 7 pi over 3, we're adding 2 pi. If I want to add fractions, what has to be true in order to add fractions? Same denominator. So this guy can be 7 pi over 3, but this guy needs to be over 3 as well. So the top is now going to be 6 pi over 3. 7 pi over 3 plus 6 pi over 3 is 13 pi over 3. That is how you add fractions. Don't let that be hard. I know it's kind of funky and everything else we're doing, but you can handle that. Don't let it be weird. Really, notice that the fastest way to do this, if I want to add 2 pi to 7 pi, take the denominator, double it, and add it to the top. So we take 3, we double it, we get 6. You add that to the top, I get 13. Okay, that's how we're going to add 2 pi. If you need to write it out, but we shouldn't be too bad. We're dividing fractions. If I want to divide two fractions, what are we really going to do? Multiply by the reciprocal. So I would multiply by 3/5. The 3's would cancel. I get 2/5. That's how you divide fractions. Multiply by the reciprocal. Again, not something you don't know, but just making sure we're all on the same page. Questions are there. Last one. Okay. 4 cosine squared theta plus 8 is equal to 10. Our job is to find the mistake and then solve it correctly. So we're going to go thumbs up, thumbs down. Give me thumbs up, thumbs down. This red step. Thumbs up, thumbs down. We're good on this red step. We're good. That was an easy step. We just added 8. Thumbs up, thumbs down. We're good on the blue step. Good. We're good to that point. We divided by 4, so we got 1/2. Thumbs up, thumbs down. We're good on the black step here. We're getting some thumbs down, and I agree with that. In this portion of the graph, it was incorrect. What did they do wrong, Sophia?
They didn't square root the 2.
Yeah, they didn't square root. They acted like they square rooted, but they didn't square root. And this happens all the time with my students. They're going to write the square root of 1/2 and then say that the answer of the square root of 1/2 is 1/2. It happens quite a bit, right? So we take the square root of 1. The square root of 1 is 1. But the square root of 2, I got to do that. Do you know what the square root of 2 is? Me neither. So we could leave it like that, 1 over square root of 2. Or we can simplify, or we could rationalize. I get radical 2 all over 2. Oh, that's what it's supposed to be. All right? So that is the mistake. So I'm going to go back and get rid of the rest of this stuff. That was the mistake. Okay? When they tried to take the square root, they did it incorrectly. The square root of 1/2 would be radical 2 over 2. What else would I need to include there? Plus or minus, because I took the square root. Everybody with me at that point? Now we just solve it just like we would. We're doing getting rid of cosine. So to get rid of cosine, we're doing inverse cosine. So over here, that's going to cancel. Over here, inverse cosine of plus or minus radical 2 over 2. That means I'm looking on my unit circle, and I'm looking for everywhere that cosine, that my x is radical 2 over 2. So it is all of those answers. I don't care if it's positive or negative, okay, because it was plus or minus. Both answers, or all 4 of those answers work. My answer to that question is pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Questions on how I set that up? Again, this is a really important aspect to what we're doing, okay? I think the best way to see anything we're doing today is to graph it. So I'm going to show you that real quick. So what we just did, what was the problem? 2 cosine, 4 cosine squared theta, 4 cosine squared theta, and then plus 8, and we are trying to be equal to 10, correct? So we're going to make this equal to 10, okay? So here is my answer. Notice this blue shaded part. The blue shaded part is 0 to 2 pi because all our answers are going to live on that interval from 0 to 2 pi. That's an important aspect to what we're doing, okay? So if I look up here at this graph in between 0 and 2 pi. How many times am I equal to 10? Well, right there, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Okay, those were my answers. That squared there gave me a lot more answers. Everybody kind of see what's happening with that? Great. Let's just say, let's make it easier. So we understand that. Let's just say it was this problem right here without the square. All right, so let's just say it was this problem right here. We get pi over 3 and 5 pi over 3. A different problem, okay? But those are my two answers. Talk with your neighbor. What would happen with both the green graph and the amount of times I'm going to be equal to 10 if I change the number right here in front of x? What if instead of just x there, I threw a different number, like the number 2? Talk with your neighbor. What's going to happen to my answers if I throw that number 2 in front? That's super important for today. Talk. All right. So what is going to happen to my graph? What is putting a 2 going to change about my green graph if I put a 2 in front? It changes the period length. In particular, what's that going to mean about my graph? If I throw a 2 in front, is the period length going to become bigger or smaller? Smaller, because we multiply by the reciprocal. So watch. Whoa. Max did a great job as I was talking around. He said, it's a spring, and that spring has now been compressed. Okay? And so we're getting answers a little bit more often. So notice that now, in between 0 and 2 pi, I have 2 full period lengths. How many answers do I now have on that interval? There are 4. 1, 2, 3, 4, because I went faster. Okay? What if instead of a 2, what if I put a 3 in front? What do you think is going to happen? Well, I got 6 answers. 1, 2, 3, 4, 5, 6. Everybody see what's happening with that? Okay? It's a big difference. Okay? There were 2. What happens, do you think, if I put a 1/2 in front? There's only going to be 1 answer. Boom. Mind exploded. Now, careful with that idea. What about this one? I just want us to think. All right, I'm going to change this to sine. What happens if I put a 1/2 in front of this x? How many answers am I going to have? There's still 2. Because I'm answering the question, when is sine 1/2? In which 2 quadrants is sine going to be positive 1/2? 1 and 2. And so if I do half of it, it's like I'm doing half of the unit circle. Well, both answers still happen on the top half of that graph. Okay, something we'll get to. All right, we'll get better at that as we go, but that's the main aspect. That's what you need to understand to be good at today. All right, so you ride a Ferris wheel. This is the problem we did on Friday to end the day. Everything's the same. Okay, when you ride a Ferris wheel, you have a diameter of 40 meters. Okay, so that's why the amplitude is 20. I'm stretched up and down. You turn at a rate of a revolution every 2 minutes. That's why it's a pi right here. Okay, because instead of 2 pi, we multiply by 1 over pi. We get a 2-minute rotation. So every 2 minutes, you go to the top and back to the bottom. Okay, so here's my Ferris wheel. On that 2-minute interval, how many times am I going to be 41 meters, or the very top of the unit circle? How many times am I or at the very top of my Ferris wheel? How many times am I going to reach that? Just once, right? How many times am I going to be 21 meters, or the middle of my graph? How many times am I going to do that? Twice, right? Because I got to go up, and then I come back down again. I hit it twice. Everybody understand what I'm saying there? We just talked about this. What is going to change about my Ferris wheel, about my graph, if I change the number in front of t? What is going to happen? It changes the period length. Not only does it change the period length, how many times am I going to be 21 meters off the ground? Is that going to change? Yeah, it's going to change the solutions, the number of solutions more specifically. It's going to change the solutions and change the number of solutions. Okay, that's the main aspect that I need you to get today. Okay, you've got 3 different equations, 1, 2, and 3. I've given you 3 graphs down below. I want you to match which one of those graphs goes with which equation. Notice that on equation 3, there's a blank there. They're missing a number. Okay? As you figure out which one that one goes with, figure out what that number should be in front. Talk. Go. All right, here we go. Graph number 1, this guy up here at the top, or this equation right here. Show me with your fingers which one goes with that equation, A, B, or C. Which one you got? A, B, or C? We're saying C. Herman, why do you think it is C? Good. It had 4 solutions compared to the other one, and we just talked on decimals that if I throw that 2, it's going to speed us up. It's going to have twice as many answers. Lovely. Okay, we could have talked about period length as well, since the period length now is only 1. Right there gets me a full rotation, so I'd want a 2 in front. Show me with your fingers which graph is going to match here with number 2, the one with the 3 in front. Show me the fingers, A, B, or C. Number 1, so we're saying A. Why do you think that, Lydia? Why do you think 2 is going to match with A? Good. It's got the most number of solutions. Specifically here, it has 6, and that 3 in front, yeah, we're going to get more rotations. And then obviously that means that number 3 is going to go with B. What number? Show me the fingers. What number do you think is going in front of pi? Yeah, 1/2 should be going in front of pi. Notice that we're only getting a half of a period length, right? And up here we had a full period length in that time interval, so I'm only getting a half, so I throw a half in front. It should make sense, and I have half as many answers as well. Questions to this point? All right, let's do it. We're solving this thing on an interval, okay? This part of this is so important. This is what determines everything about this problem, is that interval right there. So question A says tangent of 2 theta equals negative radical 3. So let's solve that. Everything we know about solving, we can still do here. I'm trying to get theta by itself. I want to get rid of tangent. How do I get rid of tangent? Reverse tangent, otherwise known as inverse tangent. Yes. Inverse tangent is negative radical 3. Now, that's not your favorite thing, but you can do it. Inverse tangent, okay, that means I want y over x to get me negative radical 3. So which thing needs to be radical 3, the y or the x? The y. The x needs to be 1. So I'm looking at my unit circle, and I'm trying to figure out when is my y going to be radical 3? Well, right there my y is radical 3 and my x is 1. Is that the one I want?
No.
Why not? It's got to be negative according to our problem, so I want the negative ones. All right, so cool. There we go. 2 pi over 3 is one of our answers because my y is radical 3 and my x is negative 1. Is there any other answer? 5 pi over 3. Down here, y is negative radical 3. My x is 1. Good. 5 pi over 3 is the other one. Those are 2 places where tangent could be negative. Everybody good to that point? Cool. So we just mosey back on over here. We write down our 2 answers. And if this were a normal problem, I would be done. But the problem here is that I have a 2 in front of my theta. And that 2 in front of my theta is going to cause me some issues. Everything we've talked about so far today has been worried about that 2. What does this 2 do to my graph? Crunches it down. It speeds it up, right? If this were a Ferris wheel, what would be happening on my Ferris wheel? I'm going faster, okay? I like to think that this 2 right here represents 2 times around. Because the answer to this, the questions are all going to be on that same interval, okay, from 0 to 2 pi. So the interval doesn't change, but by changing that period length, now I can go around the unit circle twice in that same amount of time. Okay, so think about what that means. I start here. I go around. Boom, I hit one. There's an answer. Boom, I hit it. There's an answer. But I'm going all the way to 2 pi. So that means I'm going around again. Boom, I hit it. There's a third answer. Boom, I hit it. There's a fourth answer. Okay, I'm going around the circle 2 times because the period length changed. So, how do I show that I'm going around the circle again? How do I go around the circle again in radians? We are going to add 2 pi to my answer. Well, I've got to add 2 pi to fractions. And so if I'm going to add 2 pi to fractions, what should I get? Common denominator. So I want the denominator to be 3. Well, what's the numerator going to be if I'm adding 2 pi? 6 pi. This is kind of silly. You don't have to write this to the side, but I want you to understand what we're doing. To show that we are going around 2 times, I need to add 2 pi to my answer. So this is what I got the first time around. Now I'm going to take this and add it to these answers to get my second rotation. So I'm taking 2 pi over 3 plus 6 pi over 3. I get 8 pi over 3. I take 5 pi over 3 plus 6 pi over 3. I get 11 pi over 3. I now have 4 solutions. Am I done? No, because I still got that 2 in front. I got to get rid of the 2. The 2 told me I had to go twice as fast, but I still need to get rid of the 2. How do I get rid of 2? We divide by 2. If I'm dividing by 2, what can I do if I'm messing with fractions? Multiply by the reciprocal. Basically, we're just taking the denominator and multiplying it by 2. And so that tells me this. My answers are going to be 2 pi over 6, 5 pi over 6, 8 pi over 6, and 11 pi over 6. And we could simplify, obviously. Notice that they're all the same denominator until I finally reduce. And then some of them could switch. Are all of those answers between 0 and 2 pi? Are all of those answers between 0 and 2 pi? They better be, because that was the whole goal of the problem, was to get answers between 0 and 2 pi. Okay, so again, we solved like normal. The 2 in front of theta caused a couple different mistakes. I got to add 2 pi because I'm going around 2 times, and then I get my answers. Again, I think it's super important that you get a visual for this. Sorry, I'm trying to find my equation. All right, so here's what you had. Okay, you had tangent of x. Let's just graph that, and we wanted to make it y equals negative square root of 3. Okay, so here's my original graph. Here are the 2 answers we found, 2 pi over 3 and 5 pi over 3. That's what we wrote down. But what happened was this x value changed. Okay, we threw a 2 in front of that x, and so it went twice as fast. So when I went twice as fast, now how many answers are between 0 and 2 pi? Now I got 4 of them, pi over 3, 5 pi over 6, 4 pi over 3, and 11 pi over 6. Okay, it allowed us to go faster, which gave me more answers. Make sense on that? Let's try it again. Negative 2 sine 3 theta equals 1. Get 3 theta by itself. Don't move from there, but try to get 3 theta by itself. Go. All right, here we go. So negative 2 sine 3 theta equals 1. I'm going to solve, Jack. What'd you do first? Divide by negative 2 on both sides. Good. Now he's got this. Sine of 3 theta equals negative 1/2. Then what, Max? Or not Max, sorry, Sam. Inverse sine. We're doing inverse sine on both sides. Okay, so inverse sine. So Sam's looking for everywhere that sine is negative 1/2. So we're looking at y's. We want to be negative. So not in the first quadrant, not in the second quadrant. It would only be in quadrants 3 and 4. When my y is negative 3/2. So 7 pi over 6 and 11 pi over 6. Everybody go with me till that point. 7 pi over 6 and 11 pi over 6. And that would be my answer if theta were by itself, but it's not. I got this 3 in front, and that 3 causes a lot of havoc. What is that 3 doing to my graph? Speeding it up. How many times am I going to go around the circle if I'm still looking on my interval from 0 to 2 pi? 3. That 3 means 3 times around. So these are the answers I got the first time around. What am I going to do to find the answers I get the second time around? I'm adding 2 pi. All right, and in this case, it's over 6, so it's like I'm adding 12 pi over 6. You don't have to write this to the side. I'm just doing it to help us out. Okay, we're adding 12 pi over 6. That's the ugliest 12 ever. Deal with it. Okay, so the second time around, I'm adding 12 pi over 6. So 12 plus 7 is 19 pi over 6. And 12 plus 11, that's 23 pi over 6. Those are the answers I got the second time around. Am I done? I need to go a third time around. And so I'm going to take these answers, that 12 pi over 6, and add them to these answers. Because I'm going around again. So 12 plus 19 is 31 pi over 6. And 12 plus 23, that is 35 pi over 6. I have 6 answers, which is what we thought, because we're going 3 times around. We should have 6 total answers. What do I need to do with each of those answers now? Divide by 3, because there was a 3 in front. To get rid of it, I multiply by a third. Okay, multiply by 1 over 3. So basically, all that does is it just changes my denominators. My answers are going to be 7 pi over 18, and 11 pi over 18, and 19 pi over 18, 23 pi over 18, 31 pi over 18, and 35 pi over 18. Questions? Let's look at that real quick. So, -2 sine x, y equals 1. Yeah, the first time around, 7 pi over 6 and 11 pi over 6, those are my answers. But we threw a 3 in front. What's going to happen? 3 times as many answers. It changed it quite a bit. Here are those answers: 7 pi, 11 pi, 19, 23, 31, and 35. Kind of makes sense what's happening. Be careful with this idea. What if instead of a 3 in front, what if I threw a 1/2 in front? How many answers would I get on this problem if I throw a 1/2 in front? I would get 0. Why? When do these two answers that we found initially, 7 pi over 6 and 11 pi over 6, which 2 quadrants are those in? 3 and 4. So if I do a half of that, I'm not getting to those 2. I'm only looking at quadrants 1 and 2. So look, when I throw a 1/2 in front, not like that. That's garbage. Let's throw that in parentheses, perhaps. If I throw a 1/2 in front, it is going to make it be, oh yeah, nothing happens. There's my first answer, but now it's outside of the interval. Okay? Stick with me. Show me with your fingers 0 through 5. How are you with that value? By adding that number in front, how'd we do? It's something you got to practice. Okay? We're going to have practice time throughout the week, so you will get better. At first glance, I know it's strange, but you'll get better as we spend more time with it. We just don't have enough time to do it forever. All right, let's look at letter C. Letter C. I think letter C is easier. Okay, we're on the interval from 0 to 2 pi. This time we're not changing the period length, we're shifting it. We're horizontal shifting. The good news, it's not going to affect quite as crazy as the last one. I want to get rid of tangent. How do I get rid of tangent? Inverse tangent. And so I am thinking, all right, inverse tangent is going to be theta minus pi over 2. I'm thinking about where on my unit circle is tangent going to be between 0 and 2 pi. When is tangent going to be 1? I'm sorry. When is tangent going to be 1 between 0 and 2 pi? So it needs to be positive. So which 2 quadrants am I thinking? 1 and 3, because tangent's got to be positive. And so, right there, tangent's going to be positive because it's radical 2 over 2. And, right there, tangent's going to be positive because it's negative radical 2 over negative radical 2. So the 2 answers I'm looking for are pi over 6. Or I'm sorry, pi over 4 and 5 pi over 4. That's where tangent's going to be 1. Okay, so those are my 2 answers. Let's write those down. Pi over 4 and 5 pi over 4. That's when tangent's going to be 1. Great. Those are my answers. But what do I need to do with those answers? Add pi over 2. I am taking these 2 answers and I need to add pi over 2. Now, you might not like this, but you can do it. Okay, I'm adding pi over 2. So if you have to, write it out. I'm taking pi over 4, and I need to add pi over 2. But I need to get common denominator. So I would multiply this guy by 2 over 2 on top and bottom, which would get me pi over 4, plus 2 pi over 4, which would get me 3 pi over 4. You can add fractions. You might not like it. You might have to write it out, but you can do it. That is an answer, 3 pi over 4. I'm going to do it with the other one. So I'm taking, again, 5 pi over 4 plus half. So this plus that. So if I added that together, it's 5 pi over 4, and I got to get the other one to have the same denominator, so it's 2 pi over 4. 5 plus 2, 7 pi over 4. There is my second answer. Now, that's good, but make sure your answers work. Here's what I mean by that. Is this answer, 3 pi over 4, is that on the interval from 0 to 2 pi? 7 pi over 4, is that on the interval from 0 to 2 pi? Yes, they both are, and so both of those are going to be my answer. Okay, let's look at a visual of this so you can make sure you see what's going on. So here was my graph. I'm going to shade it because I like that aspect of it. 0 is less than x is less than 2 pi. Okay, so my answers need to be between there. So at first glance, I've got this answer right here at pi over 4 and pi over 5 pi over 4. But then what did we do? Did we add or subtract? We subtracted. So if we subtracted, we are shifting the graph. Which way are we going to move if we're subtracting? To the right. So watch those dots. Boom, they moved over. Oh, we moved over. We moved over pi over 2. Are those two answers still on the interval? Yeah, we're good. There wasn't anything going on there. What about this? What if instead of shifting it to the right, what if I would have shifted it to the left? What would have happened with my answers if I shifted it to the left? Talk with your neighbor for a second. What happens if I shift to the left? So if I shift to the left, I'm taking this guy and I'm doing this. Watch, ready? 1. Oh, I shifted over. Is this negative pi over 4 an answer anymore? No. By shifting it to the left, it got kicked out of my interval. But how many answers do I have? I still have 2, because why? The other one popped in. As one gets kicked out, a new one comes in. Okay? Because what is negative pi over 4? Oh, negative pi. I could say negative pi over 4, or you could call it by its other name by adding 2 pi to it. Oh, yeah, that's 7 pi over 4. It's still the same thing. Okay? If one gets kicked out, a new one should get kicked in. Does that make sense? Try the next one. Go. Try letter B. Or D, sorry. All right, so we're solving here. Kara, what'd you do first here to solve? Divide by 2, divide by 2. That goes away. Cosine of x plus 3 pi over 4 equals 1/2. Wonderful. Then what, Kara? Inverse cosine. She wants to get rid of cosine, so she's doing inverse cosine. All right, so again, in this capacity, it means where on her unit circle is cosine going to be a positive 1/2. All right, so we're looking at our unit circle. When is my x going to be 1/2? Oh, right there, x is 1/2 at pi over 3. And boop, right there at 5 pi over 3. Those are going to be my two answers. Pi over 3 and 5 pi over 3. And that's all well and good if x were by itself, but it's not. I've got the 3 pi over 4. So what do I still need to do? Subtract 3 pi over 4 from each of those answers. So again, if you're not good at fractions, then write it out. I'm doing pi over 3, and I'm subtracting 3 pi over 4 from those answers. So minus 3 pi over 4. Okay, I'm going to take 5 pi over 3 and minus 3 pi over 4. So if I wanted to write them with the same denominator, it's like I multiplied this one on top and bottom by 4. So 4 pi over 12 minus, multiply this one by 3 on top and bottom, 9 pi over 12. I get negative 5 pi over 12. Same thing down here, multiply top and bottom by 4. So I get 20 pi over 12. Multiply this one by 3 on top and bottom. So it's minus 9 pi over 12. And I get 11 pi over 12. Those are my two answers. But are they my answers? Are they both, again, the whole idea is between 0 and 2 pi. Are they both between 0 and 2 pi? This guy is, but that guy isn't. Negative 5 pi over 12 is no longer in it. So what do you think I'm going to have to do to find out what that really is? Add 2 pi. We're going to figure out what it would be the next rotation around because it got kicked out. If something gets kicked out, a new one gets brought in. And so really all we're doing is adding 2 pi to this thing. Well, if I'm adding 2 pi, it's like adding 24 pi over 12. And so my new answer is going to be 19 pi over 12. That is my second answer to this question. And again, this is why I think Desmos is so important today, is because I need you to get a visual of what just happened. Okay? Here was my problem. I lived in between 0 and 2 pi. I need to live on that interval. Okay? If I take this, it's so dark, I got to change it. Okay? We've got these two answers. I've got this answer right here. And I've got this answer right here. Okay? Those are my two answers. And I'm shifting it. Is it plus or minus? It's plus. So if I shift plus, I'm taking these things. That means I'm shifting them left. So boom, boom, boom. Oh no, there's my negative 5 pi over 12. It's outside. Okay. Oh, there's 11 pi over 12. But as this one went out, a new one came in. And there it is right there, 19 pi over 12. Okay. It's 2 pi away. Kind of makes sense. We'll get better. Tomorrow, again, we're going to do the same thing, a little bit different, but the same idea. Let's skip E for now, because E is just calculator. It's easy. I'm not that worried about it. Let's go to F. Okay, I'm going to work with this together because I'm going a little bit long because I'm recording. Okay, let's solve. What am I going to do first? Divide by 2, divide by 2. That goes away. Sine squared. Theta over 3 equals 1/2. Then what? Square root, square root. So sine of theta over 3. I'm taking the square root of 1/2. We did that already in bell work. What is the square root of 1/2 going to get me? Yeah, if you don't remember, go back to bell work here. But it was square root of 2 over 2. Okay? What's the problem? What else do I need? Plus or minus. And so I'm going to get rid of sine. I'm doing inverse sine. So what that means is I'm looking on my unit circle for everywhere that sine is plus or minus radical 2 over 2. So right there at pi over 4, at 3 pi over 4, at 5 pi over 4, and at 7 pi over 4. Pi over 4. 3 pi over 4. 5 pi over 4. And 7 pi over 4. Notice that this problem's a little bit different. Notice that it doesn't say your answer is between 0 and 2 pi. It says write a single general formula. That's weird. Okay, what that means is it's going to happen infinitely. It wouldn't stop at 7 pi over 4. It would happen again. When do you think the next one would happen? 9 pi over 4 and 11 pi over 4, because it's every half a pi we keep hitting these things. And it would go on forever. I don't want to write them forever. Okay, but understand that's the premise. Is theta by itself? What else do I need to do to get theta by itself? Multiply each answer by 3. And so what that means is theta is going to be 3 pi over 4, 9 pi over 4, 15 pi over 4, and so on. But that's not really my answer either, because it asks for an equation for the answer. Okay, which actually means it's easier, because you don't have to write out all these answers. Think back to when we did domain. It's very much the same idea. When did our first answer happen? 3 pi over 4. That is my first answer. And then it's going to keep repeating over and over again. Okay, forever and ever and ever. How long does it take in between my first answer and the second answer to happen? I'm adding 6 pi over 4 to that answer. And then the next one, how much do I have to add? 6 pi over 4, and then 6 pi over 4. Oh, it's nice because it's nice and evenly spread out. And so I'm going to just say 6 pi over 4n. which means I'm just going to keep doing that. I'm going to multiply by 1, then multiply by 2, and so on. Obviously, you could simplify 6 pi over 4. I'm going to leave it as is.